All right, let's go ahead and get started. Got a couple of equations I want you at your seats to analyze and graph. Analyze and graph. We've got f of x equals negative 1 plus the tangent of x, and f of x equals 2 times the secant of x. Take just a few minutes. If you need to go back in your notes, do so. But take a few moments to work on these, and then we'll look at them together as well. We'll go back and look at your notes. Don't do the wrong, do the right. For the tangent curve, class, what is the period of tangent?
Pi.
Pi, which means the entire tangent graph, remember, is done by pi. That said, we generally graph it out to 2 pi. So what are my key points of tangent, class?
0, asymptote, 0, asymptote, 0.
Good. 0, asymptote, 0, asymptote, 0. Where in between the 0 and the first asymptote we have a
1.
and between the 0 and the second asymptote,
-1.
-1. And since that's one full period, you're just going to see the same thing again with a 1 and a -1 there. However, I see this -1, which tells me I'm going to shift the entire curve down 1. So I'm going to go through and draw a, let me switch to white here for contrast, and let's go down to -1. And there's my x prime axis. So relative to this line, 0, asymptote, 0, asymptote, 0. And in between, in the first quadrant, up 1, exactly halfway in between, down 1, up 1, down 1. Now there are a couple other points if you wanted them. At 30 degrees, what would be the tangent? That first box, 30 degrees over pi over 6, what would be the tangent of 30? You can always use your calculator if you needed to.
0.57.
Yeah, 0.57, about 0.6, a little bit bigger than 0.5, square root of 3 over 3, right? And so you could put that in there if you wanted an extra point. Of course, you'd have to put it negative in the second quadrant, positive in the third, negative in the fourth. You could also do 60, which is your next box over, if you wanted to, especially if this were graded or something, right? You'd want it to be very, very accurate.
1.7.
1.7, so again, here's 1.5, 1.7-ish, again, down 1.5.7, right about there, 0.5.7. And then we're just going to curve the graph up and approach, but don't touch the asymptote. Also, don't go parallel and don't go away from it. Approaching, not touching, but not running parallel. That got maybe a little closer than it should have. I may need to go back and erase some of that. We'll just cut it off right there. And there's a graph of our tangent curve that just shifted down 1 unit. And there we go. So again, if you went back in your notes, saw the tangent curve, shifted all down 1, you've got your graph of -1 plus tangent x. How many had something like this on the first graph? Okay, Ethan, good questions from the rest of you.
So even though it says like period is pi, we still will do it to 2.
We just so it doesn't, because all the other functions other than tangent and cotangent graph to 2 pi, so we do tangent to 2 pi also, even though the period, yes, is done here, right? All this is a duplicate of this, right? So you just get to see the whole thing a second time with tangent and cotangent, right? Good. By the way, what is the domain of the tangent?
All numbers.
Right, all real numbers. This keeps going and going and going, except where there are asymptotes, right? Which would be at pi over 2. 3 pi over 2? So in other words, n pi over 2 when n is odd, right? So it's all real numbers except at n pi over 2 when n is odd. By the way, what about the range of the tangent?
All numbers.
Yeah, all numbers, all the way down to infinity, or negative infinity, all the way up to infinity. Questions on the first graph? Let's take a look at the next graph. For the secant, what's the period of the secant curve?
2 pi.
2 pi. And remember I said with secant, my suggestion is to base everything off of cosine. What are cosine's key points?
1, 0, -1, 0.
And I said to make the secant, just take the reciprocal of these. Well, what do you get if you take the reciprocal of 1?
1.
What about the reciprocal of 0?
Asymptote.
Undefined, which we're going to make an asymptote. -1 stays -1, 1 stays 1. So that's my key points for the secant. 1, asymptote, -1, asymptote, 1. Let me go ahead and erase some of this excess here and
There's
see if
also
we can.
amplified with the 2 right before, right?
Mm-hmm. All right, so if we're plotting our key points, right, we'd have the 1, then the asymptote here, which I guess means we could have just used the same asymptote and just erased. Then the next -1, then the asymptote, and then back to 1. But we're going to stretch everything out to an amplitude of 2, as Ethan points out. So instead of starting at 1, it'll be 2, asymptote, -2, asymptote, 2. So starting here at 2, then the asymptote, then at -2, then the asymptote, and then back at 2. Now remember, what the cosine curve is doing is it's dropping down and going up. But we're going to take the reciprocal of all of that, right? So normally, right, if we had 1, 0, negative 1, 0, 1, we said up against the zeros class we would have halves and negative halves. Negative half, half, right? Well, we're going to take the reciprocal of those to get 2's and then double them to get 4's. So here near the asymptote we should be at 4. Here near the asymptote we should be at negative 4 and negative 4. And then here by the asymptote we should be up at 4. And so our curve is going to go up rather steeply, down rather steeply, almost a tight parabolic look now to it, and something like that. What is the what's the domain of the secant curve rather?
All numbers except when n is even.
Except n pi over 2 when n is odd. Right, so again, how you write that is all real numbers except at n pi over 2 when n is odd. And it's important because if you just say when n is odd, what n? Unless you specify except for the n pi over 2, right? What about the range?
All real numbers.
Negative, negative 1.
Right, normally, now we've got the amplitude to 2, right? But normally negative infinity to negative 1, and then 1 to infinity. Here it's negative infinity to negative 2, and 2 to infinity, right? Because of the amplitude change. Questions on this? Questions? All right, practice with just a couple of these for homework. If you would, go ahead and write your homework down now, and then we're going to transition right back into that ACT prep. So your homework this evening is to graph 2 more functions. F of x equals negative cotangent 1/2 x. F of x equals negative cotangent of 1/2 x. And f of x equals the cosecant of x minus 2 pi over 3. F of x equals the cosecant of x minus 2 pi over 3. Go get those copied down. We'll take a look at those tomorrow. Are looking ahead toward a quiz tomorrow over tangent, cotangent, secant, and cosecant graphing. Of course, got to be able to do vertical shifts, horizontal shifts, amplitude, inversion, period change, all that fun stuff as well. And this time, go and get out your ACT practice test. And let's pick up where we left off. We left off on number 30, so we're going to pick it up with number 31 today. Picking up with number 31. Today, get your calculators at the ready as well, if they're not already out, like mine wasn't.
I'm so stupid. I didn't print out front and back. I just printed all on one side, so I have like 9 pages here.
It's okay.
We all are stupid sometimes.
All right, number 30. I didn't say that. Okay, it's true though. All right, number 31. Vector I represents 1 mile per hour east. Vector J represents 1 mile per hour north. Okay? Maria is jogging south at 12 miles per hour. One of the following vectors represents Maria's velocity in miles per hour. Which one is it? Well, if she's going south, which vector, I or J, goes with that? J, but it's not quite J, right? Because J is north. She's going south. How would I show that? Negative 12 miles per hour, right? But each mile per hour is J, because that's north, so we would say negative 12J, letter B. It's just kind of algebraic representation, if you will. Questions on 31? All right, number 32. 4 identical glasses are shown below. One glass is empty. The other 3 glasses are a fourth full, a half full, and 4/5 full of water. I would say we have empty, and 3/4 empty, 1/2 empty, and 1/5 empty. Anyway, just never mind. All right. Glass half empty, glass half full.
Yeah.
All right. Duct tape you. All right. So it says, if the water were redistributed equally among the 4 glasses, what fractional part of each glass would be filled? So we have to see how much glass fullness we have. We have nothing, we have a fourth, we have a half, and we have 4/5. I would add this all together on your calculator. Now, I did it with a common denominator, which is annoying, okay, but you could do it on the calculator, so do that now. I'm going to add that all together on your calculator. What do you get when you add it together? 31/20ths. Now, you might have gotten it as a mixed number 1 and 11/20. It doesn't really matter. That's how many glasses worth of water we have. We have 1 and 11/20 glasses worth of water, or 31/20 worth of glasses full of water. If we were to redistribute it among the 4 glasses, what would I need to do mathematically? Divide that by 4 on the calculator, or multiply by 1/4 if you're doing it by hand, which is just sad, which is what I did for no good reason. And what fractional part of each glass would be filled? 31/80ths. Letter K is our answer. How many had that answer? All right, does it make sense now if you missed it? Does it make sense? Because again, we're not filling just 3 of the glasses, we're filling all 4 of them, including the guy that didn't have any to begin with. All right, number 33.
I had that, by the way.
Aurelio is purchasing carpet tiles to cover an area of his living room floor that is 8 1/3 feet wide by 10 feet long. Each carpet tile is a square 20 inches wide by 20 inches long. Do we see a problem?
The things don't match up.
Yeah, feet and inches don't match up. So instead of 8 1/3 feet, multiply by 12 on your calculator to get 100. Okay. That's 100, really? Okay. By and then 10 feet would be how many inches? 120. So how many square inches does he need to carpet?
1,200.
12,000. All right. We got 120 and then stick 2 more zeros on the back end of 120. So we need 12,000 square inches to be carpeted. Each tile is 20 by 20, which is how many square inches? 400. So we just divide by the 400 square inches in each tile, and we get
300.
Careful. 30. 30 tiles required, letter D. Which is good it's not 300, because otherwise we'd be in real trouble. 30 square inches. 30 tiles, excuse me, needed. And of course they'd have to be cut perhaps, right? They wouldn't fit perfectly maybe, but they could be cut to the right size and made to fit. Questions 33? Yes, sir.
Oh, no, sorry. I thought, never mind.
All right. Number 34. In the standard XY coordinate plane, a circle with its center at 8, 5 and a radius of 9 coordinate units has which of the following equations? Here we go.
I had no idea how to do this, so I guess.
So you might recall I said if the circle is centered at 0, this is the equation that I gave you when we were going through the other previous ACT prep. Well, here they didn't keep it centered at 0, okay, which I don't normally see that from the ACT. What you really have is x minus 0 squared plus y minus 0 squared equals r squared. But if it's not centered at 0, if instead it's centered at 8, 5, then we'd have x minus 8 squared plus y minus 5 squared, and the radius they said is what? 9. So if we square the 9, we get 81. Again, this is something we're going to do a lot next semester in pre-cal. It just doesn't help you now. So again, this is if you can remember it, great. If you don't, well, so you miss 1 out of 60. It's not going to kill you as long as you get the stuff you should get. Did anyone get letter F?
I got, but I was trying to do like an educated guess.
Yeah, so if you remember the r squared, that helps to narrow it down, right? And then it's just a matter of, the weird thing that we're going to memorize is that it's minus is default. Which again, normally we think positive, so you have to actually think inverse of what it is. Again, if you miss it, oh well, It's not something you've learned yet. The purpose of the ACT is to see what you've learned. That's coming, you just haven't learned it yet. But again, if you can remember that, great. If not...
If we all do great on the ACT, it looks really good on you.
I guess. It doesn't really matter. I've got job security, so it's not like I'm worried about losing my job. Now, if I were worried about losing my job, I'd be panicked and telling you all to do great on your ACT. And I'd be like, forget what I'm supposed to teach you in pre-com. I'm going to teach you what you need for this.
We're gonna do something illegal. Every problem, you're gonna learn all of them.
All right, let's see. Number 2. Page 2. Number 35. There we go. I was like, where's the question number? It's way down here. So there's a lot of stuff about this stuff. Many humans carry the gene YQ77. YQ test determines with 100% accuracy whether a human carries YQ77. If a YQ test result is positive, the human carries the YQ77 gene. If a YQ test result is negative, the human does not carry YQ77. Okay, so like positive, negative test, in case you didn't know what that meant. Okay, but in other words, this test is like, it's not like the COVID test. Like this is like 100% accuracy. You definitely have it, definitely don't. There are no false positives. There are no false negatives. All right, Sam designed a less expensive test for YQ77 called the Sam77 test. Hey, you invent it, you get to name it after yourself, right? Like Newtons and Pascals, right? You get to name it after yourself. All right, it produces some incorrect results. Okay, there's some false positives, some false negatives. So again, I'm not knocking the COVID test, right? Of course there's going to be false positive negatives when you rush something through really fast. Well, that's what Sam did. He rushed it through really fast. It's not 100% accurate yet. Oh well, okay? But it's pretty good. Both tests were administered to 1,000 volunteers. We're trying to see how accurate the SAM77 test is. Results from the administration are summarized in the table below. All right, so 1,000 tests given. Notice 590 people had a positive SAM77 test. 25 people had a negative SAM77 test. 10 people tested negative for the YQ test. Oh, excuse me, 590 people, here we go. 590 people who tested positive on SAM77 also tested positive on the YQ test. However, 25% of the people who tested positive on the YQ test tested negative on the SAM77. You get the idea? There's 25 fake negatives on the SAM test, right? Everything's right with the real YQ test, but the SAM test had 25 false negatives, okay? They said you were negative when you were really positive, okay? Then there were 10 people who tested positive for the SAM77, but were really negative on the real YQ test. So there's 10 false positives. Got the idea? And then there's 375 where they tested negative on both. So really, how many wrong tests were there total? Before we even start looking at questions, like how many
35.
people, how many?
35.
35, right. 10 false positives, 25 false negatives. So they're out of 1,000, that's only 35 false tests. That's not that bad, right? 3.5% error, that's pretty good. Good job, Sam. And it's less expensive.
Better than the COVID test.
For real, okay. So here we go. It says it costs $2,500 to administer a YQ test, but it only costs $50 to administer the SAM77 test. Yeah, I'm all in on the SAM77. What was the total cost to administer both tests to all the volunteers? Well, again, how many people took both tests? 1,000. So that's 1,000 people costing $2,500, and those same 1,000 people also cost $50. So how much do they cost total?
2,550,000.
Yeah, 2,550,000. Letter E. Okay, just multiply both numbers by 1,000, add them together, or you add them together then multiply by 1,000, which is quicker. How many got letter E on 35? Make sense? All right. Number 36, what percent of the volunteers actually carry YQ77? Well, how many people tested positive for YQ on the real test? How many real YQ positive tests were there?
500.
No, that's how many tested positive YQ and positive. Really, there were 615 total positive YQ tests, right? You had 590 who also tested positive on the SAM test, but there were 25 who really were positive that SAM said were negative, right? The 25 false negatives. There were really 615 true positives. Out of how many volunteers? 1,000. So 615 out of 1,000 volunteers carry YQ77. So what percent is that?
J.
Letter J, 61.5%. Does that make sense? Sam would have said 590. Or excuse me, Sam would have said 60%, right? Because he had 600 total net positives, but he's wrong. There were 615 total positives. Letter J for number 36. Number 37. For how many volunteers did the SAM77 test give incorrect results? Oh, we already answered this one.
35.
35, letter C. Didn't mean to get ahead of myself. I didn't remember that being one of the questions. It's just one of the things that interested me while we were first looking at the table.
That table is kind of weird though. Like
Yeah,
the-
I was having a hard
Yeah,
time.
you notice it took me a second even, because again, I did this a few weeks ago, so I'm like, now how do we read this again? Oh yeah, I got you now. These are all the positives, these are all the negatives, these are his positives and his negatives, so we kind of see what the difference is. What?
You made that?
No, I worked this a few weeks ago. I printed it off for me, I solved all the problems first, checked my own answers, and then I'm giving it
How
to
long
you
did
guys.
it take you to do it?
30 minutes-ish.
Then when I was reading it, I read the SAM77 test and YQ test.
As the two columns, and it's not. These are positive and negatives, those are his positive and negatives. Let's see, number 38. One of the volunteers whose SAM77 test result was positive will be chosen at random. What's the probability that the chosen volunteer does not actually possess YQ77? Okay, so for this we have to think, how many people tested positive on Sam's test?
590.
Nope. 590 real positives, and then he also had some fake positives.
600.
600, right? 600 total positive tests for Sam, right? Now, of those, how many were false positives? They didn't really have it.
35.
No. There were 35 total false tests, but how many were false positive tests? Like Sam said they're positive, but they were really negative.
10.
Only 10. So out of the 600 total people that he tested positive, right? 10 of them weren't really positive. So 10 out of 600 were false positives. What percent is that?
63.063.
Nope. 10 out of 600.
0.0166.
Or rounded the nearest thousandth, 0.017, which is letter F. Okay, does that make sense? So one of the things I did on my chart, so you got Sam 77 positive, Sam 77 negative. YQ positive, YQ negative. Okay, so Sam's tested 590 people positive. Sam tested 25 people negative who also had positive YQs, right? So these are all accurate. These are sad. Okay, he tested 10 people positive that should have been negative. Those are sad. He tested 375 people negative, which really were negative. So these are accurate results. These are his bad results, right? That means 600 total positives for Sam, 400 total negatives for Sam. 615 actual positives, 385 actual negatives. I put these totals on the bottom and side so I could see it a little bit better. Does that make sense? So maybe something like that on a chart type problem would help you to get the total numbers. And notice this line is not one that they provided. You see that? They didn't give you that line. I put that line in just to help me process the differences. So anyway, table reading. Some good stuff there. It's kind of more science classy type of stuff too, right? How to read the math and read the results. All right, let's go to page 27. Matrices. Oh, it's been a while, hasn't it, since we multiplied matrices. Jamie, it's been a couple of years for you, and I don't think we ever made it to matrices with you. Let's review. Now, fortunately, they gave you a little bitty matrix.
I don't like the way he laughed, kind of like a devilish laugh, when he said, let's review.
I always laugh that way. It's just my nature.
It scared me.
Yes, quite. So, remember when you multiply, this is a one row by two column matrix. This is a 2 row by 1 column matrix. And as long as the inner dimensions match, you can multiply. The outer dimensions tell you the dimensions of the answer. So XY matrix is going to be a 1 by 1. When you multiply, you drop this number down here, this number down here. So I end up with -1 times -2 is +2, and 0 times -1 is 0. 2 plus 0, 2. There's my answer, letter D.
Yeah, I didn't get that right.
Pretty easy.
If you remember how to do it, right? Now, so let's do a quick refresher here. Because it's been a while. Now, granted, you're probably going to only have one matrix problem on the entire test. Okay, so I don't want to belabor this too bad. But if I had matrix A, and let's say matrix A was 3, 2, 7, -1, 5, 1. And let's say matrix B was
I think we did get through this.
-12, 3, -4, 5, 0, 7. To add matrices, they have to be exactly the same size. So these are both 2 row by 3 column matrices. Okay, so we can add them. An A plus B matrix, you literally just add corresponding terms. So when I add the first 2 terms, I get -9, 5, 3. Positive, so be careful.
Yeah.
Then
4,
4,
5,
5, 8. So adding matrices is super easy. Okay, if I wanted to take like a scalar multiplication like 2b or not to be, that literally means you double everything in matrix B.
24.
-24.
6. -8. 10. 0. 14.
Okay, so scalar multiplication, really easy. If I were to subtract matrices, A minus B, you would just add the inverse. So what I had suggested to you when I taught it to you was before you do the subtraction, change all the signs and make it a negative B, like a 0, doesn't have positive, negative, then add up. So I get
15,
negative 1, 11, negative 6, 5, negative 6.
There we go. So subtracting matrices is really easy, but addition, subtraction, they have to match. But to multiply, again, multiplication of matrices was the harder one. If I had a matrix B, to multiply, it'd have to be 3 times something, because the inner dimensions would have to match. Maybe we make it a 3 by 1. Okay? Well, that means that my answer is going to be a 2 by 1 matrix. But let's see, I need, so 2, 1, negative 3. Okay, so 3 rows, 1 column. My answer, AB, is going to be a 2 by 1. Where I'm going to have a number here and a number here. What we do is we take this first row and we drop it down here. We're going to multiply corresponding terms. 3 times 2, 6, and I kind of pencil that in. 2 times 1, 2. 7 times negative 3, negative 21. And we add those numbers together to get negative 13. That's the number that goes here. Then we're going to take the second row and drop it down now. Negative 1 times 2. I kind of write that in small. 5 times 1. And 1 times negative 3. And then I add those together to get 0. And there's the answer to my matrix multiplication. Frankly, you hope that on the real ACT they give you an addition problem, okay? But it was a relatively small one, but that's as far as we didn't do much more than that with matrices. Yes.
We got to the adding matrices, we never got to the multiplying matrices.
Probably not, yeah. The multiplication was it's ghastly, especially if you had bigger ones. Like if this were a 3 by 4.
Now let's not do this.
Yeah, you get the idea. It could be huge, the whole problem when it works out. So yeah, if you wanted to, well, I can't send you back to YouTube to rewatch that because I haven't recorded it yet. So yeah. I guess you can find your old Algebra 2 notes, good luck. Or just pray that it's addition of matrices that shows up on your actual test.
Between a rock and a hard place right now.
Pretty much. Do your best and guess. Let's see, number 40. Regardless of how a graph is oriented, the standard XY coordinate plane, no graph in one of the following categories has a vertical line of symmetry. Which one? Well, which one of these, class, could not possibly have any symmetry?
Scaling triangle.
A scaling triangle has no symmetry whatsoever. There's your answer. Right? A square, of course, has symmetry. A line has symmetry. Pentagon could have symmetry. Even a parallelogram could have symmetry if you oriented it just right. Or you could say, because a parallelogram could be a rectangle, which could have symmetry, right? So a scaling triangle, there's no way to have any symmetry with that. We're just, stuck. And that one, I think, makes pretty logical sense. All right, number 41. That equation has 2 solutions. Which is the greater of the 2 solutions? What kind of equation is that? Quadratic. And when we solve quadratics, we set them equal to 0. So I move the 15 over as a negative 15. Hopefully you did as well and set it equal to 0. And then hopefully you tried to backwards one. We'll factor it, right? Maybe split up the 24x squared into
12 and 2.
I could.
6 and 4.
Yeah, I'm thinking either probably 4 and 6 or 3 and 8. Let's try the 4x, 6x because they're closer together, right? Negative sign? Positive, negative. The 15's got to be
5 and 3.
surely 5 and 3. And I'm not going to put the 3 with the 6. So I'm going to put the 3 with the 4 and the 5 here because notice there's no common factor. So I couldn't get a 6 and 3 together with a common factor. Let's see if this works. Outer, inner. Close. Just need to change the signs. So that actually worked out pretty well, right? And if you tried the 12 and 2, it wouldn't have worked. So then you try the 3 and 8, that doesn't work. You eventually get the 4 and 6. Now, question. When you set each of these equal to 0, what are your 2 answers for x?
Positive 3 and negative 5.
Well, positive 3 divide out the 4, and negative 5 divide out the 6. So which is the greater of these two? 3/4 is bigger than negative 5, 6, so 3/4 is our answer. Letter A. Questions on solving quadratic equations. Number 42. Which of the following expressions is equal to sine of 60 cosine of 30 plus the cosine of 60 sine 30? This is something you are going to learn in about 2 weeks, but maybe less than that. But it's not going to be in time for your ACT, SAT. So what you could do, okay, you could actually go ahead and multiply. So on your calculator, take the sine of 60 times the cosine of 30. Call it out.
0.75.
Exactly.
Yeah.
All right, cosine 60 plus times sine 30. Call it out.
0.25.
0.25. And what do you get?
1.
1. All right, now then, you can do in your head what 60 minus 30 is, right? Is the cosine of 30 1? Picture the unit circle.
No.
No, when is cosine 1?
Uh,
At 0, right? Cosine line is 0. Or you could, okay, then 60 plus 30 is 90. Maybe you don't remember, so you take the cosine of 90.
0.
But it's 0, so that's not it. Then we know 60 minus 30 is 30. Is the sine of 30 1? No. What about 60 plus 30? That's 90. What's the sine of 90?
1.
Ah, okay, so it seems like it's j. Just to be sure, what's 60 plus 30 divided by 2?
45.
Is the sine of 45 1? That means it must be j. Now you're going to learn what's called sum and difference identities in about a week or so. Again, it's going to be after you take your ACT. That's going to make it really, really easy to do that. You can look at it and know the answer, but you haven't learned it yet. So we're just a little behind. I've never seen a sum difference identity on the ACT practice test before, by the way. So this is the first time I've seen that. Yes?
So the answer was J?
The answer is J. And again, you can
I got
figure
that.
it out with your calculator, but there's a better way. I don't have time to teach it right now because we're going to get to it later. Number 43. What is the area in square units of a circle that has a circumference of 12d units long? So here we got to think, what's circumference, what's area? Well, circumference of a circle is the formula
2 pi plus r.
2
Pi.
pi
R.
r. Not 2 pi plus r, just 2 pi r. And then the area of a circle, pi r squared. Okay, this comes back to your junior high days, all right? So we know the circumference of a circle is 12 pi units long. So 2 pi r equals 12 pi. Well, let's cancel away the pi's and the 2's to get r equals 6. Well, if r is 6, then what's the area? 36 pi. And there it is, letter D.
I was doing so well in the first 2 pages, and now I'm doing
All right, but that's just junior high math, right? So know your formulas. Okay, and by the way, I think
I had to look back on the other one.
they actually don't give you that. They expect you to remember your formulas. That's the one thing you can say for the SAT. They don't expect you to remember the formulas. They give them to you.
I don't know which one.
All right, number 44. A barrel contains 25 liters of a solvent mixture that is 40% solvent, 60% water. Okay, stop. I stopped right there. It's like, okay, what is 40% of 25?
10.
10. What's 60% of 25?
15.
15. Okay, so we have 10 liters of solvent. We have 15 liters of water. We all good? That's 25 liters total. Now Lee is going to add pure solvent to the barrel. So we're going to keep all 15 liters of water, but he's going to add more solvent to it. Does that make sense? So we're going to go above the current 25 liters total. He wants to get to a point where it's 50-50. Well, how much would he have to add to go 50-50? 5 more liters of solvent, right? 5 more liters of solvent, you get 15 and 15 for a total of 30. So how many liters of pure solvent should he add? 5. Super easy if you start by finding those numbers. Make sense now? Number 45. If x does not equal positive negative y, which, by the way, remember, denominators can never equal 0. So if you set your denominators to 0 or unequal to 0, you'd get that x can't be positive y or negative y. What's that equal to? Okay, get a common denominator. This is literally Algebra 1, Algebra 2, adding fractions. So remember back in Algebra 1, we said if you have a polynomial denominator, factor or group it. Do you remember hearing that? So we would group the x plus y and the x minus y. And then it said to add fractions, draw a big long line, put the LCD below it. Everybody needs representation. X plus y needs representation. X minus y needs representation. Or in other words, x squared minus y squared if you were to simplify, right? Okay, so then, what changes from here to here? Poof, there's an x minus y, right? So multiply x minus y. See, now it matches. But also, what you do to the bottom, got to do to the top to get
X squared minus y over x squared.
no, x squared minus xy. Here, what changed from here to here?
X plus Y.
the x plus y. So multiply x plus y. And what do we get in the numerator?
XY plus Y squared.
xy plus y squared. Notice that the xy, negative xy and xy are going to cancel. What does that leave us with?
X squared minus 2.
X squared plus y squared over x squared minus y squared. And there's our answer, letter E. Just basic algebra.
Can I say no?
Sure. Oh, open that window too, that'll help.
Yeah. It's all the way. Or?
Yeah, all the way. Push it all the way up. There we go. I had it open earlier and somebody was complaining they were cold. Now in your case, you could take off the hoodie and that way you're not so hot. You're sweating. All right, questions on 45. All right, number 46. Mary, James, Carlos sold quarter-page advertisements for the school yearbook. Mary sold twice as many as Carlos did, and James sold 3 times as many as Mary did. Oh, this is like ordinary word problem from like Algebra 1. Who gets to be X? Carlos, because that's who it comes back to, right?
Oh, yeah.
Mary sold twice as many as Carlos, James sold twice as many as Mary, but Mary's already defined in terms of Carlos, right? So let's let Carlos be X. Mary sold twice as many, and James sold 3 times as many as she did.
6X.
All right, so total, they sold
9x.
9x. And of these, what fraction of these advertisements did Carlos sell? Well, he sold x out of a total of 9x.
1 over 9.
That's 1/9. Right, x over 9x is 1/9. So he sold 1/9 of the advertisements. How many had letter F? Good. Number 47. In a window display at a flower shop, there were 3 spots for 1 plant each. So there's like this little display thing. Plant 1, plant 2, plant 3. Emily has 6 plants to choose from. So she could put she's got plants 1 through 6. It could be 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, 6, 5, 3, 6, 5, 2, 6, 5. There's a whole different bunch of ways she can arrange this, right? Positions of the unselected plants do not matter. Okay, so remember back in Algebra 2, toward the end of the year, we talked about combinations and permutations. Going way back, right? And we said if the order doesn't matter, then that means that we would take, I think this would be a combination, because permutation order matters. Like finishing first, second, third is not the same as like if Quentin finishes first in a race and Chris is second and Ethan's third. That's not the same as Chris finishing first, Quentin finishing second, and Ethan finishing third, right? I don't know why you're always last in the race there.
Slow, I'm fast.
Yeah, that's what it is. He's just sluggish. But a permutation says that's different, right? Quentin finishing first, Chris second is different than Chris first, Quentin second, even though it's the same 2 spots. But a combination just says, hey, these are the 3 top finishers. So I think what we need here is a combination of 6 total items, and you can only choose 3 of them. So on your calculator, we'll take 6, and then remember this notation NCR. N is the total number, R is the number selected. So we do 6, second function NCR 3, and that can't be right.
Where's NCR at?
It's got to be a permutation then. I'm getting combination and permutation mixed up because it's been a while since I've looked at them. It's the second function of the 9 key, is the permutation key. Oh! That's what threw me off. Okay, because when you do take a combination, right, you get you 20, which isn't an option. So I'm like, well, it can't be a combination, then it must be a permutation. Look at the note. I actually underlined this, and I didn't remember why I underlined. The positions of the unselected plants do not matter. Duh! The unselected plants sit in a warehouse. Okay, so the position does matter then. Position of the selected plants, no, it is a permutation. So second function, 9 keys. So it's going to be 6, second function of 9, which is the NPR, 3 equals. And there's the 120 positions, which I had for my answer. That would have really messed me up if 20 was an option, though.
I had a good guess on that one.
The position of the unselected plants. Why would they even say that? I don't know. It's just confusing. Pick up your calculator. At least it wasn't a TI-30XA that you dropped. It's some lousy Casio. All right, questions.
Cassio's better than all this.
Discrimination. All right, questions on 47. Discriminating against the Casio. All right, we're going to move quickly because we have only 4 minutes left. Tell you what, shut the door if you would, Ethan.
We're about to go fast.
Now, in case we go slightly over, yeah, we're cool.
5 minutes over.
All right, number 48. In terms of A and B, what's the area in square coordinate units? All right, so what shape is that? Well, it's obviously a triangle. Notice from M to P is the base of the triangle, right? And then, so how wide is the base from M to P on that graph grid?
4A.
4A units. So the base is 4A. From the base, go straight down to Q. What's the altitude of the triangle?
5B.
5B units, correct? And to find the area of a triangle, we said T equals half BH. So there's your altitude, there's your base. What is that?
10AB.
10AB. So letter G, your answer. Just basic area of a triangle. Number 49, point M will remain fixed, but point Q will continue to move right along the x-axis. As Q continues to move to the right, which of the following statements describes what will happen to the slope of MQ? Now look on your picture at MQ. What kind of slope does MQ have? Negative slope, right? And if Q continues to move, the slope will continue to be negative. Will it increase or will it decrease?
Decrease.
Well, right now, the slope is, say, a rise of like 5, run of 2, right? If we're thinking without the A's and B's, it's a slope of 5 to 2, but negative 5 to 2. If the run increases, it'd be like negative 5 to 8, negative 5 to 73, whatever, right?
Let's stay the same.
So is the slope increasing or decreasing?
Decreasing. Well,
How does negative 5/8 compare to negative 5/2? It's greater. Picture the number line. Here's 0, negative 1, negative 2, negative 3. Here's negative 5 over 2. Here's negative 5 over 8. Here's negative 5 73rds. The slope will increase, but it'll stay negative.
It'll never be positive.
Right, because as the denominator increases, the run, which is what the Q is doing, that's running, right? As the run increases, the denominator increases, the value drops, right, of the fraction. But since it's negative, it becomes less negative, meaning it increases. So the option is letter D. It'll never be positive. And you could have just guessed just off that part. Forget the it will increase. That's maybe what I did. I was like, well, it's never going to be a positive. The only option is D. Because everything else talks about eventually be negative. Well, of course it's going to be negative. Not eventually be, it already is. Never be negative, that's a lie. It already is negative. It'll stay the same. Well, that's stupid. Of course it doesn't stay stupid. It doesn't. It'll eventually be positive. No, it can never be positive. So maybe that's all I did. Maybe I didn't even look at the increase-decrease thing. Number 50. One of the following values is equal to f of 5a. Which one? Well, where is on the graph, which is the parabola, that's your function f, what is the f of x or y value for 5a?
Q.
yeah, 5B.
Where, what is it?
5B.
5b?
That I have.
No. On the function. The function is the curve. Notice how it has the arrow saying this is my f function? So where you see 5b, what's the y value? Or 5a. What's 8? 8b.
Yeah.
So find on your parabola, 5a, go all the way up, mark a little dot, that's at 8b. Does that make sense? The function is f. Do you see how to read the chart? We've got a little triangle that's kind of sketched in there, MQP, but the function itself is f, where n is the vertex. Questions on that, how to read the graph. All right, number 11, we got 12 jurors. You know what, we're going to have to finish this next time. We'll finish those last 4, 51 to 54. Homework already been given to you. We're going to take the quiz first. Well, go over the homework, take the quiz, then we'll wrap up these last 4 problems from your ACT practice test, rather than go over by too much.
There's 10 more problems. We have 60.
Oh, 10 more problems. There's a backside. Okay. Yeah, very good that we saved that then. 51 to 60. These last problems required more explanation than the first 30, apparently. Have a good day.